Okay, so today it's a Moonraker Master hand portable. It's a long time since I've seen one of these. It comes in a box and it's from somebody relatively local at Boston here in Lincolnshire. So what's that, 28 miles away? I don't think I've ever seen a box for one of these. They do work well, and out of the plastic handhelds, yeah, I know the Realistic 1001's plastic, but it's got the range boost side panels. Out of the, shall we say, the cheaper plastic handhelds, we've actually had 8 miles out of one of these. And that looks, it's got the dummy batteries in there, it's got the case, it's not got the instruction book. Okay, are we going to be able to get in here? And now follows a 40-minute video on trying not to destroy the freezer bag. And the original product bag, I think this calls for the duster. Before we even start, check the aerials in one piece. It is. Right, what have we got to the real world? We've got earphone sockets so we can plug it into the test gear. We've got 12 volt socket, we've got an aerial socket, and I think they are 12 volts. I don't think I've got a instruction book. I've got a circuit diagram coming up, which is a redrawn circuit diagram. I think, what shall we start with? What shall we start with? Does the... No. So the plug, so it must be 2.5 millimeter. Let's go and get one of... no, I think we've sold out at the moment, Midland 77805. I'll tell you what, we'll use the... oh, is that a 77805 lead? Yes, it is, Mr. Tango. Right, we'll see whether we can do it that way. And it's positive centre, so that's good. So we have got a 77805 lead on the bench. We'll get that connected to our famous crocodile clips, which I will spend the rest of the afternoon shorting out for a laugh. So 12 volts it is. That's why you get dummy batteries with it. Let's see if there's any clues on this redrawn circuit. So we have had one of these before. I don't think we've had one as a customer repair. Yeah, it's 12 volts. I think these were very late 80s, like 1989. Just see if there's any anything on his letter. No. And I've forgotten what he said in his email, so we'll go through it. Important. You can use the high-low power switch. 50% of the battery is saved if you possibly can. It's 1991. A little tiny bit later than I thought. 1080148. So what we got? Oh, they have a meter on these, don't they? So high-low power. Yep, quite comprehensive. So we're going to need our adapter SO239 to Motorola. It's longer than phono. These were originally what were put in the back as scanners. In the days of crystal controlled scanners, they had a Motorola aerial socket on the back, and this adapter enabled you to use this type of connector with those type of scanners. But subsequently, CB walkie-talkies have ended up with what looks like a phono socket. So we'll power this up. And there it sits. It's an LC7137 synthesizer. Of course, you can take that off. I mean, we're at 60 milliamps at the moment. We're at 100 milliamps if we've got the display on. So we'll switch picture-in-picture on, and we'll go to the 3-watt scale. And at the moment we're doing 440 milliwatts. So chances are that's low power. So I may as well jot that down. And now, that didn't do anything. That's better. 2.9 watts. .7 watts. That's interesting. Normally you'd end up with it being more on lower frequencies. 2.9 watts. Back to channel 20. Current consumption 936 milliamps, which is actually a lot for that kind of output. We won't have got a VCO method. What we will do is have a quick look at deviation on this test set for what it's worth. Wallow, wallow. Can't see any. Wallow. Can't see any audio. Let's put our talkie-walkie on. Testing 1 2. Testing 1 2. That sounds like a dirty PTT switch. Audio probably goes through that. And on receive, oh, it's still frequency. .2779.121, it's spot on. By the time the gear's been on another half hour, it's going to be probably need to come down actually. Anyway, we'll put that into the signal generator. 2779. We're at 100 microvolts as well. 121. I'll do. So 100 microvolts, we've got an S9 showing on the meter. That's right. So we'll plug our SINAD meter in. I'm not sure how we're going to get an earth if we need one. I probably don't need an earth. But no. There's bound to be negative earth on a set like this. So put the SINAD meter on. And just put enough volume on for a sensible trace. So I'll show you that sensible trace on the oscilloscope. There's a sensible amount of volume, so that the AGC in the deviation meter is how it wants. Oh, that's not good. It's not good at all. Wow, that is awful. You sure this isn't a Cobra to be that bad? Right. It's still showing S9, isn't it? Or is that battery meter? No, it's a bit of BS, I'll tell you what. So we've got 2.1 microvolts for 12 dB. .8 for 10 dB. I'm sure they're better than one of these. And to get 20 dB, we're looking at 1, 10, 11, 12, we're looking at 13 microvolts. So Squelch, just turn the volume down. Squelch on full. I think they're pretty wishy-washy being a handheld. We can't open, and that's going to be because the receiver's so far out of alignment. Never opens. Let's see whether it will work at the more sensitive end. Yep. Got 1 point. No, we've got 4.8. So I think at the moment, top of the hill would be about as far as we would get range-wise. So, is this a return or is it major finger trouble? Right, we'll get the power turned off. As you can see, the transmit is pretty close. So I think somebody's probably tweaked it up in inverted commas and just turned everything. I haven't got a coin to open that, so we'll use the long nose pliers because we can. Yeah, I mean it's had batteries in it, but even the foam is still okay. That should be the right screwdriver. Now you kind of take the top off, but you take the sides off, etc, etc. I think it may be easier to take the top off this, and that hopefully will release the back. to one side. Yeah, that was the right approach. Still not quite out of the woods yet. I need to recover. The screw. So I think we're going to be best off unsoldering everything. So I'll put the soldering iron on. What's all this? What has gone on here? Is it being turned into a play toy? Is this one we're going to send back? Don't put Roger Bleep in it or something stupid. Oh my goodness. See what an immaculate case hides? I just soldered my finger. Right, we'll put that on one side. Now, which ones of these hold the board in, and which ones of these hold the board to the chassis? Is that just the only one? I think we'll just disconnect it from everything. Who's beginning to think somebody's trying to make this do external mic? Which it can't. Yeah, so they've got all this going, all these stupid wires going to the PTT. But you can't have the existing switch and then add a secondary one. It's supposing you put a relay there, because you've still got this in receive when the relay's in transmit, so then you're in receive and transmit at the same time. So it is a bonkers idea. Just buy a set that's got external mic if you want external mic. These aren't the build quality you want to be fiddling around like this. Right, well that's got rid of all that stupid wiring. So now we've got to make it do audio. So I think we're going to have to take this board out. So is there any component in here, or is it just rolls of insulating tape? Okay, we've got a little 2.5mm socket. So if we'd placed bets on what was going to be with this set, I would have said it's an immaculate radio, it's just a retune and test. No way would I have expected all this silliness. Do these people do things like this to their cars as well? So we'll put enough of this together. I don't like seeing that spring. Where's that come from? I'm not going to make those too tight. I think I'm going to disconnect this speaker as well. Right, so we can plug external speaker in there. I can if I plug it in. Yeah, that was earphone. We want power. And then we want aerial into here. Right, power back on. So far so good. Back into transmit. Put the main meter back up. Wallow. Testing 1 2. Wallow. I think we've got audio. Testing 1 2. Testing 1 2 1 2 1 2. Very, very low audio. 1 2 1 2 1 2. Now, whether or not I've got a damaged element or we've got a dirty PTT switch, just take the power off again. Because chances are the audio runs through that. So I'm just going to wiggle that around, get some service-all switch cleaner in. So we may end up having to get another mic insert in that. I've got some scrap handhelds. There's a nice realistic American one there, which is probably a candidate, but not legal here, so no use, and so scrap. Testing 1 2. Testing 1 2. Testing 1 2. Testing 1 2. So, which is deviation as a quick test. Or are we going to have to print this out A3 so I can actually see it? So the microphone's there, and deviation is RV4, RV2, RV1. It's going to be under there, isn't it? It's going to be under there. We have to take all the screws out again, aren't we? No, RV4 is get-atable from here. So, see what, we'll use the little oscillator. And we'll put that on there. One, two, one, two, wallow. Oh, no, that's not going to do anything. So very, very quiet transmitted audio. So we're still back to, until I've fixed that, I don't feel like doing anything else to it. What happens if they've shorted out the power supply? Because it has an electret condenser mic, it has to have power. So if they've shorted that out, there's all these what ifs. I'll tell you what I will do. I'll just see if we can get something more out of the receiver, because I don't want to carry on if the receiver's been blown up. So it's too deaf to be anywhere like normal. So if we can just see the kind of alignment points, just to see if we can get somewhere with the receiver. So detector's going to be that. Just put the oscilloscope up. Let's put some volume on. Well, there's one reason why there was lousy audio. Now, we've now got it down to 0.74 microvolts. That's going to be the IF. A bit more signal on. And looking at the oscilloscope, the SINAD meter, and this meter, we can peak this one. There's our telltale, we can. So that IF was out as well as the detector being out. Now they're quite a simplistic receiver, if I remember rightly, like the Harvard 410 is, so they're going to be a bleed over box, but that doesn't matter. It's T1, I think it's T1, T2. It's definitely T2 and T3. I think we're looking at those two, but it doesn't matter if I cock it up because obviously I've got the test gear to put it right. I think all the synthesizers, I think everything down there is going to be to do with the synthesizer. Let's just see whether we get a difference. Let's drop the signal so we can see. It's good because you can see it on that meter. I'm looking at the SINAD meter. See whether that's received. Yep. I'm going to drop the signal because I now I know it's received. We can do it on the SINAD meter, which I'll show you. So is this receive as well? Is this broken one receive? Yes, it is. So right now we've got 0.47 microvolts. So cock up a modification to add a mic, which you can't do, and then make the receiver deaf. It's just under 0.4. It's 0.39. And then for 20 dB, yeah, we're in there. It's at 1. We're on the edge. I'll tell you what, I'm not going to be that generous. It's 1.05. And that should have fixed squelch. So full squelch. Let's put the attenuator up. And where does that now open? 1, 3, 10. It doesn't, does it? It's still not wanting to. So one of these is going to be a squelch preset, probably in the wrong position. So here's our FM chip. Chances are it's got built-in squelch. So S meter is RV1. So RV1 is there. Squelch is RV2 and RV2 is there. So let's turn that down so we've got something coming through. Let's see where we are now with the sensitivity of the squelch. I mean, that isn't ideal. No, that isn't ideal at all. Of course, if they've put external power in inadvertently by adding this socket across the microphone, they could have blown up the transistor there. 2SC 1815 I think it is. Now, one of the tests we can do is to see whether I've got audio on that deviation control. So if we put our finger on the microphone hot there, of course we should get a buzz or a screwdriver or something like that, but we should get a small buzz on the preset. So we can do that without any further costs. So we've got plenty of audio there. You see where I'm coming from, can't you? So if we just put that round, we should have tons of audio at the microphone connection, but we haven't. So I think they've blown up that transistor to SC 1815, which is a very straightforward transistor. So I'm going to have to take a break, and whether or not we can return to this today is another question. Okay folks, well we're back onto this a bit later. I didn't show you everything that's done. We've got audio back. Yeah, they'll have shoved power up it, won't they? So took out transistor 17 here, so your microphone's there. We'd already checked there was power going to which was. I didn't spot that capacitor. I would have changed this as a matter of course. Changed the transistor there, changed the capacitor there, and we've changed the deviation preset as a precaution. So let's put that to one side. Now with it in bits, testing 1 2, testing 1 2 3, Wallow. Right, I'll get some screws back in this, and then we'll see whether there's anything that can be done with the squelch control, or whether the whole thing's a waste of time because the squelch doesn't work. The time I've put into this would take it into our third charge band level, rather than our second charge band level, and I haven't the heart to do that in view of what he's paid for it. And there's no mention that the transmitted audio is virtually non-existent. And I noticed the person's got other CB radios on, which he's selling right now, and that includes a realistic 1007 with a broken arrow, which he says is in good working order. Well, if it's got a broken arrow, how can it be used? Can we have an explanation as to how it can be used if it has a broken aerial? Or do these people not know about SWR? He's not like giving it away. Look at our customer, he could hear people on this, and considering how deaf it was, must have been doing some funny power level. Right, so we've already done the receiver. There's not a lot we're going to do with the transmitter. It's already doing 3 watts, and they don't really do 4, so I'll just run through these adjustments here and try not to short out the aerial output to the rod. So going to transmit. It's there somewhere. Helps if I put an aerial in, doesn't it? Right, make sure we were in low power. Now we're in high power. So it's 3.3 now. I'm just going to put it to 12.8 volts, which is the highest I dare. Uh, 3.6 watts. It's not often you get hand portables over 3.5. Are you going to end up with massive battery for the use for the tiny bit of range you're going to gain? So. Well, I've going to put all that in the wrong box. Tell you what we're drawing, 983 milliamps. Yeah, I think that's about the safest we're going to go. So we've got to get to the bottom. Well, really we have, as to why we've got no squelch operation. Just to see how this... Oh, there is an RF meter adjustment, RV3. No, I haven't spotted that. Oh, it must be that one there. Must be that. So we'll just check. Go into transmit. RV3. Just wants to be touching that. So that's definitely that. Just looking how they connect this aerial. Okay, T7, T8, T9, there's T7. That was definitely receive. T8 and T9 are here. There's no need to touch any of that because it's doing the power. So we've overcome that problem. So Squelch, we've got that preset. So unless I'm on a false lock point, there's something wrong with the Squelch. Transformer 4, am I on a false lock point? Well, that's obviously transformer 4. Right, we'll go back into receive. Better plug our external equipment in. 100 microvolts. Oscilloscope on. Let's look at the oscilloscope. Because for the squelch to not work, my calculations are there's got to be something wrong with the IF. So there, we're just not getting anywhere. So we'll turn up the volume sufficient for a sensible trace. See if this is on the wrong lock. So you've got a second point there, which is not much volume. Got the main one there. No, that's the main one. I'm going to turn the squelch up. No. So I can have got the IF totally wrong. Let's put the signal down. Kind of see as it comes in for a split second. Yep. Right, we better set the deviation. I'll see if I can set it on this test set first, because it'll be easier. Wow. Wallow. Right, I'll just plug into the test set behind. I've set it kind of up roughly, but we never know what this one feels like, so we'll go to the other. This is going to be fun. Let's unplug the speaker. Something I don't have to drag across the bench. Wow, it's a bit loud. Wow, that's spot on. So here's the question. Was this, I think the phrase is farted about with, used as a play toy and killed? Did that happen in 1991? Or did that happen last year? Has this set not worked since it's been messed with and wrecked? Okay, so we need to get a chip for this hand portable. It's the next kind of move a week later. I've done some research, and it's a copy of a something which is a development of a MC3359. Now we've got here a DNT high-tech handheld, and we've got a, I think this kind of works, but it's seen better days. So what's the value of this radio? £10? If that's what it is, then that's what the chip will cost the customer. There you go. Sometimes that's all we're going to be able to do. Oh yeah, of course it's a CPT set, isn't it? Yeah, that's why it's only worth a tenner to me. So I'd rather have a 2781 set working for the customer than a CPT set. And it's the battery holder on this is corroded, so something we bought in a batch, so that's its value. Right, we'll try and get this unsoldered in one piece. I'll start by soldering it up. Right, I need to check all those pins are clear. If not, we'll get the desolder braid to anything that isn't. Shall we use a metal screwdriver? Actually, I think we'll pause this video because otherwise we're going to go in with a 2-hour repair, aren't we? You get the gist. That's 2, that's 3, that's 4, 5, 6. Not quite on 7. 8's clear. So anyway, I'll pause the video. So hopefully, we're having unsoldered that, we can get the chip out. Not sure why it's not wanting to come. Now we'll have to... I wouldn't normally go to this trouble, but they've paid such a lot for this radio. And of course I've fixed half of it, haven't I? Right, we'll put that on one side. And now we're going to have to do the same with theirs. And let's take the chip out. It's got the added complication of this resistor. Move that out of the way, and we'll remember it goes there. In fact, put a mark on the board, and then we'll do exactly the same again and remove this one. Right, so I've got the old chip out of the... Managed to lose one pin, not surprised. So, made sure that the holes are clear. I'm going to make sure the pins are lined up to go in from the wrong side. Let's go for it. Right, go with the isopropyl alcohol. A little bit up there wants sorting out. and nobody would know that wasn't factory. Right, we need to put that resistor back. And we took one of the transistors out to test. Right, at the moment of truth, we're going to have to disconnect the, I may as well do that now, disconnect the loading coil once again. Just going to have to retune the receiver. So if you remember, the problem was we got Squelch operation as far as the knob goes. So I'm just going to turn it on. We're on channel 20, still good. So we've got the FM hiss, which proves the chip works. We've got Squelch operation, so we've got no change. Now I'm going to put the signal generator on. This is where we'll know whether it's fixed or not. So I'm now on at 0.3, it's not come on. It's 3 microvolts. The Squelch has opened. And we'll go through the tune-up. Right, so I've made sure the set's retuned. So we're about 0.6 microvolts for 20 dB, which is where we were. So if I turn the signal generator to standby, park it at 0.3 like we usually do, set the squelch to threshold, switch the signal generator back on. We're looking at 2.5 microvolts, so it's not good. It's not good. 2.5 microvolts for Squelch opening, and then if we put it to full Squelch, which is there, put the signal generator back on. Full Squelch, looking at 2 millivolts or something like that, so it's very short range for the Squelch, but it does work. And it didn't before. I'll go for a break and I'll leave it on 19 and we'll see whether any bad buddies come through. All the wires placed just right. They've all got to go in their grooves. So without putting the top on, oh, it's lighting up some bars now. Perhaps it had a dirty preset. Squelch, channel, volume, right, we'll try once again. Okay. Let's turn the signal generator off, set the squelch, squelch working, even though it's a crummy range. But talking about the other usage of the word range, of course we've had, what, 8 miles on one of these ones? Right, we're now on the aerial. One and a Roger. We did actually hear some people talking on it earlier in the day when it was on the aerial on test. So there we have it, the Renault Master. My van's a Renault Master. This is a Moonraker Master. A lot of work there, and immaculate radio, totally ruined by some wally. And I just felt so sorry for these people, because it would have gone back otherwise as beyond economic repair, because I know how much they've paid for it. So there we go. It's got a nice box with it. We'll do an on-the-air test from the bench, but because of the squelch, even now it's working, you know, it's got very limited range, and to have a squelch sensitivity of, I'll need to amend this, it's 2.5 microvolts. It's probably about 13. So, you know, this is what we spotted before. Right, there we go. So it's had transistor, IF system IC, 3 times capacitors, and that's about it. Lots of work. So thanks for watching the Moonraker Master from about 1990.